So the first thing we'll talk about with regard to your logbook is the idea of permanence. So if done correctly, your logbook is a legal document. It can be submitted to a court of law. You could, for example, use it to prove that someone was trying to steal your patent. But in order for it to be admissible as a legal document, there's some things we need you to do, and they all have to do with the idea of permanence. That is, your logbook is supposed to be a permanent record of all your work, and you're not allowed to remove any information from your logbook after the fact. So first of all, you need to use a logbook that has glued in or stapled in pages. The reason for this is that if you used a spiral-bound notebook or loose leaf pages, that wouldn't be acceptable because if a page went missing, how would anyone know? So you need to use a book that has permanently bound pages. In other words, it has to have glued in pages or stapled in pages. When it comes to what you write in your book, you never want to obliterate information. So for that reason, use permanent ink only, and if you need to make a correction, cross out the error with a single line, and then write your correction nearby. The point here is that the mistake is still readable. You have not removed any information from your logbook. So you should never use whiteout, you should never scribble something out to the point where it can't be read, and you should never tear pages out. So your logbook is a permanent record of everything you did, including the mistakes, and that means the mistakes need to stay readable. So cross them out with just a single line. Likewise, don't write your data on a piece of scrap paper. That rough work also needs to be recorded permanently in your logbook. So write it directly in the logbook, not on scrap paper. If you want to recopy it neatly later, that's okay, but it's not even really necessary. Neatness does not count for anything. The completeness of your record does. So a messy logbook is totally okay. You can have things X'd out, arrows, comments in the corners, it's all fine as long as it's a complete record of everything you did and legible enough to be understood. So now let's talk about the specifics of what you put into your logbook. There's something we need you to do on every single page. As soon as you turn to a new page, sign and date it or initial and date it. This goes back to your logbook being a legal document. You're attesting that you did this work on this day. Another thing that you're required to do is to write down the time regularly as you're working. So I recommend that you also write down the time as soon as you turn to a new page. But I'll explain more about the timestamps later in this video. If you're just starting an experiment, then you should be at the top of a fresh page and you should write down the title of the experiment. And also at the beginning of a new experiment, you should write down a list of all the equipment you used and all of the files that you've used in that experiment. Now that's what you do at the beginning of a new experiment, but when you're taking notes on the experiment itself, that's when things are going to be really different than what you may be used to in other lab courses. In your logbook, you don't need to write up an objective or a conclusion or a data section. You don't split things up like that. Instead, you should think of your logbook as being a real-time diary where you write down what you're doing as you do it. So you'd perform an action and then you'd write down a note about it in your logbook. Then you'd perform the next action and you write down a note about it too. Now this is harder than it sounds. A very natural way to work is to work on a thing until it's finished and then write up your results afterwards. But this is exactly the habit I need you to break. It's exactly the wrong way to write a logbook. Your logbook is meant to be a moment-by-moment diary of what you're working on as you do it. So that means the habit you're trying to develop is to do something and write down a note about it immediately. And when you observe something, again, write down a note about it immediately. This will feel more unnatural than you realize because the impulse is to wait until you're finished and then write it up. But you simply won't remember enough of the technical details at the end. So developing the habit of writing things down moment by moment is the crucial skill to taking good notes in your logbook. So now let's discuss ways to do that. So I recommend that you be task-oriented. In other words, you'd read the lab manual and it would say, do this. Okay, consider that a task. And here's how you might consider writing it up in your logbook. Start by writing what I call a mini objective. That is, you're just saying what the task you're working on now is. You want to record all of the technical detail, which in this case would be the circuit diagram for the circuit that you're building. You also want to record the time that you started the task. For very simple tasks like this one, that might be all the technical detail that you need to record. So when you're done, you can write what I call a mini conclusion. You summarize the results of completing that task in a meaningful way. And then you also write down the time that you finished your task. So let me now explain what these timestamps are about. We do require that you write down the time regularly. You will lose marks if you don't do this. The reason why we require this is that it's an excellent habit for an engineer to develop. If you start recording the time regularly as you work now, then by the time you graduate, you will have developed a pretty good feel for how long it takes you to complete certain projects. And that means you'll be able to give your future bosses really good estimates on how long it takes you to complete a project. Also, if you're working with more than one client in the future, you'll always be able to bill them accurately because you'll have recorded exactly how long you spent working on their project as opposed to someone else's. So this page shows you the kind of notes you would take for a very simple task. So now let's look at how you would take notes for a more complicated task. So after you build a circuit, probably your next task would be to test it. So you would write down an appropriate mini objective for that task and the time that you started. And then going forward, as you work your way through the task, what you want to be doing is be writing down what you did and then the results of that, so what you saw. And then you'd write down the next thing you did and what the results of that were. So here's an example. They say what they did, and then they say what the results of that were. But this is actually not good enough because the words "nothing happened" are far too vague. In your notes, as much as possible, you want to preserve the technical details. So rather than saying something vague like "it worked" or "it did not work," you want to say specifically what you observed that led you to that conclusion, such as, "I pressed the button, but the LED did not turn on." So make your observations specific. The next thing this student is going to want to do is troubleshoot. Troubleshooting is handled just like your regular notes are. You say what you did, and then you say what the results of that were. In this case, the student says what they did and puts a timestamp on it because this is effectively a new task, and then they say what the results of that were. So they read the lab manual and they learned that they missed a step. They need to make a project before their circuit will do anything. So now they're done troubleshooting and they can go on to the next step of completing this task. So they say what they're doing. This is essentially another mini objective because they're completing a task within a task. And they write down the time because you should always write down the time when you begin or end a task, even if it's an intermediate step like this one. And remember that I said you should strive to preserve all of the technical detail. So that's what this student has done. Making a project is an involved process. You have to click File, New Project, and then select Microchip Embedded, Standalone Project, and then a bunch of other settings. So this student has preserved all of that information here. And this might be a good place for me to stop and explain what level of technical detail you should be trying to preserve in your notes. So what you're aiming for is that an educated person, so somebody who knows how to build a circuit but hasn't built this circuit, and who knows how to code but hasn't built your code, who knows how to use MPLAB X but hasn't used it with this microchip, a person like that could take your logbook and reproduce the experiment exactly as you did it with no lab manual. So think about that. If somebody handed you a logbook and you had to reproduce the experiment with no lab manual, how much detail in their notes would they need to have written down for you to do that? That's what you should be aiming for. So if a stranger picked up your logbook and needed to make a project exactly the way you did, they would need all of this information. Therefore, you need to record it all in your logbook. But here's the thing. You're going to make projects every week. In fact, for some experiments, you make multiple projects. So that's a lot of writing. So you might want to consider taking this information and putting it in an appendix at the back of your logbook that you can refer to. Alternately, you can write it out in complete detail, like this, and then in future labs, you can just refer to those previous notes. So you can say refer to notes in Lab 1, or you can say refer to the appendix at the back of this logbook. Either way, be sure to list all the things that are different between the current project and the previous notes that you're referring to, such as the files that were added to this project. And remember that making a project was a task within a task. So the student's finished with that now, and they add a mini conclusion for this intermediate step, finished making project, and they record the time that they finished the task. And let's say that they now have to flip to a new page. So the first thing you do when you flip to a new page is sign and date the page, or initial and date the page, and write down the time. That can be part of your next mini objective, which is where these students are now. They're on to the next task within a task, which is to test their project. In other words, they want to see whether the project builds successfully. So they write down an appropriate mini-objective for that. And the mini-objective basically said what they were trying to do, build the project, so now they write down the result of that. Their build failed. And remember, you want to preserve as much technical detail as possible, so do write down the error message. It's common to have a whole bunch of error messages, so it's okay to write down just the first one or just the first one that you intend to fix. So now the students are troubleshooting, so they write down what they did and the time, and then they write down the results of that, so they found a typo in their code. Then they record what they did next. They fixed the typo, and they attempted to build the project again. And they recorded the time again. So try to record the time on each major step. And having recorded what they tried, they now record the results of that, which is that their build succeeded. And because that basically is the end of this task, they treat it as a mini conclusion and write down the time again. So this is basically how you take notes. Write down what you did, and then write down what the results of that were, and keep recording the time on each major step. Also, always strive to record as much of the technical detail as you can. So continuing on, they say what they did next, which is to test the button, and they record the time again. And then they say what the results of that is, which is that the LED still didn't light up. So now they're troubleshooting again, and they're just going to repeat this pattern. Say what they did, and then say what the results of that were, and then say what they did next, and what the results of that were. So obviously, when you state what you did, that could be a wide range of things. It might be, I rewired this circuit, or I read the lab manual, or I changed a line of code, or I asked a specific person for help. And by the way, do name that person in your logbook notes. But the point is, you always say what you did and what the results of that were, and you include the time and lots of technical detail. And if you do that, then you're probably going to be taking really good notes. And finishing up, they say what they did and what the results were, and because this is basically done, they treat it as a mini conclusion and write down the time. So now, without going into too many details here, I'm going to talk about some other situations that you'll see when you're taking notes in your logbook. So one of them is going to be that when you're writing code, there's going to be a big gap between when you write down what you did and when you write down what you saw. Because generally you will write many lines of code before you actually compile the project and see what it does. But you still need a good diary of all the work you did while you were creating your code. And that's what this student has done. They start with a mini objective, and it's quite a complete one, and they write down the time. And then they write down everything that they do next, step by step. So they open the code that was given to them by their instructors, and then they start adding lines of code to it. So they add some variables. And note that they crowbarred a little extra information in here. They also note that their variables were of type int and that they were initialized to 0. And feel free to do stuff like that too. Your logbook does not need to be tidy. Next, they note that they need to add some code to increment some variables, and then they give that code. They also point out that they write very similar code to increment a second variable, and you're welcome to summarize like that also. So you don't need to write every single line of code when it's appropriate to just say that it's similar to something you did previously. Down here at the bottom, they're talking about needing to create a switch to control how their LED behaves. And then over here, they're actually writing that switch out in pseudocode. And again, you're welcome to do that if it simplifies your note-taking. Remember that what you're aiming for is that someone who knows how to code could follow along through your notes and create code that does exactly what your code did based on your notes. So this is probably enough detail for them to do that. If you're doing a calculation, the best way to preserve all of the information is simply to write the whole calculation out by hand in detail. That way, if you come back 5 years from now, you're still going to know exactly where you got that number from. So another situation where you need to take good technical notes is when you're viewing a signal on an oscilloscope. So it's not enough to draw a semi-artistic squiggle and say my signal looked like that. You need to preserve all of the technical detail, and that means you need an exact transcription of what you saw on the oscilloscope screen. So you need to put it on graph paper, label your axes, put an informative title on it, and put dots on the page so that you can exactly transcribe what you saw on the screen. Remember, you want enough detail that somebody reproducing the experiment based on your notes would be able to compare what they're seeing on the oscilloscope screen to what you saw and check that they're getting exactly the same signal. So it needs to be this detailed. Of course, that's a lot of work. So luckily, Most modern oscilloscopes will allow you to save a screenshot of the signal, and then you can print that image out and paste it into your logbook. And in fact, if you don't have an oscilloscope that will allow you to do that, I consider it perfectly reasonable to take a digital photograph of the signal, as long as it's in good enough resolution for you to read everything. And then you print out that image and paste it into your logbook. One thing you would want to improve on, however, here is that you want a more descriptive title than this. So the benchmark for labeling figures and diagrams and oscilloscope traces in your logbook is that you should be able to open up your logbook 10 years from now and be able to tell at a glance, from the label alone, what it is that you're looking at. So Part A is not enough information. Put a nice descriptive title on every diagram and oscilloscope trace in your logbook. And since we're talking about things that must be included in your logbook, another thing that you are required to include is your final version of your computer code. Now, just to be clear, every week you're going to be turning in your code to me separately, in addition to your logbook, but that code also needs to be attached to your logbook as a permanent part of it. So you can clip out the important part of your code and then either glue or tape it flat into your logbook, say on the back of a page. That's the best way to attach your code, but alternately, you can also take those pages, fold them in half, and then staple one edge into your logbook to make a little booklet that you can flip through. Now, the main reason to have all your computer code in the logbook too is, of course, to have a complete record of all your work. But there's an added bonus to doing that for this course, and that is that your classroom instructor allows you to bring your logbook to your exams. In other words, the midterm exams are closed book exams with the exception of your logbook. You are allowed to read that. And often the exam questions will be something like, make a piece of code that does this, and it'll be based on something that you did in the labs. In which case, it's very handy to be able to flip back, read through your notes, look at your final code, and then use that as a basis to answer your exam question. So I'm almost done talking about note-taking. The last thing I'll say is that the purpose of taking notes is not so that some hypothetical person could reproduce your experiment, and it's not even to get a grade. It's so that you never have to re-engineer a solution that you already came up with. So for example, say in Lab 1 you learn how to output characters to the PuTTY terminal. And then say in Lab 7, you're asked to do it again, but in a slightly different way. If you don't quite remember how to do it, you don't need to figure it out, because if you took good notes, you can just go back and read them. So good notes mean that you never have to re-engineer a solution you came up with. You can come back to your logbook 20 years from now, and everything you worked on will still be well documented and easy to understand.